So in this video, we'll be solving the numericals of chapter 1A in your physics. First part, A part, we'll be solving the numericals given in your exercise. To understand the concept and the questions given in as an example, the numericals of example, please go and check the previous videos. Here I will be solving the exercise numericals. Okay, we'll start question number 1. So 1A numericals, question number 1. The moment of force of 10 Newton. So the force is 10 Newton about a fixed point O is 5 Newton meter. So force, when you are applying force of 10 Newton, it is creating a moment of 5 Newton meter. You need to calculate the distance at which force is applied from the pivot point. We have the formula M is moment of force, which is equals to F into D. Your M is provided 5, F is 10 and D is to be calculated. 5 upon 10 will be your D and 5 upon 10 is 0.5 meter. So your distance will be 0.5 meter or 50 centimeter. So another same thing. So this was your question number 1. Now question number 2. So in second question you can see the mention a nut is opened by a wrench of length 10 centimeter. So you are having a wrench and it is held to open a nut. What is length of this tool? Length is 10 centimeter. And if the least force means force is applied at the farthest distance possible. Okay, least force will be applied when distance is maximum, force is least. Okay, the force required is 5 Newton. Find the moment of force. Again here you are having F and this will be your D. Length of the tool will be the distance for the case of least force. And you need to calculate the moment. M is F into D. So it will be 5 into 10 centimeter will be first converted into meter. So 5 into 0.1. 0.5 Newton meter. So this was question number 2. And move to question number 3. Question number 3. There is a wheel shown in the figure which is pivoted at O and there are 2 points B and A. A force is applied at B as shown in the figure which is of 2 Newton. Okay. So in this particular question there are 2 parts. First you need to calculate moment about O and in second case moment about A. So case 1. The total diameter of this circle they have provided is 2 meter. So diameter is 2 meter. So this is radius, it will be 1 meter. Total distance is 2 meter and radius is 1 meter. Case 1 about O. What will be about O? What will be moment about O? Force into distance from O. Force is 2 Newton. And distance of this point at O is 1 meter. So 2 Newton meter. Okay. Then case 2. In case 2, we need to calculate about A. So moment is force into distance. At A means you are considering A to be pivoted. Okay. O is not pivoted, A is pivoted. Again your force is 2 itself and the distance is now 2 meter. So 4 Newton meter. Along with this magnitude, you should also mention the direction. So you can see here, in the first case, when O was the pivoted point and you are applying force, it is creating a clockwise movement. So this is clockwise. And similarly, when O is not pivoted, A is pivoted and you are applying the force, it is trying to rotate the wheel in clockwise direction. So this will also be clockwise. So this was your question number 3. Now I will move to question number 4. Provided in the question with point A, B and O. This is 2 meters. AO and OB is 4 meters. At A the force applied is 5 newtons and at B the force applied is of 3 newtons. Okay, so this is given in question itself. The diagram is shown, the two forces are applied. What we need to calculate? Moment of F1 about O. Only F1 at O. It's very easy. So moment due to F1 will be F1 into distance between OA, or you can rightly write F1 is 5 and here this distance will be OA. Why OA? Because force is applied at A and pivot point is O. OA is 2. So it will be 10 Newton meter. And then second part of question is moment of force F2 at O. So M2 will be F2 into distance. F2 is 3 and this distance OB. Why? Because distance between force 2 and pivot point. Force 2 is at B and this is O. OB is 4. So 3 4s are 12 Newton meter. Okay. Now part 3. Okay, we will need to mention here the direction also. So this one, if your body is pivoted here and force is applied here, it is pivoted here. If you are trying to pull it down, it will create an anti-clockwise rotation. So this is anti-clockwise. Okay. And in the second case, if you are applying force here, okay, and pivot point it is here, it will try to create a clockwise rotation. So this is clockwise. Now the part 3, total moment of two forces about O. What will be the total moment? Now total moment M will be addition of them M1 plus M2. Now I have already told you that anti-clockwise is considered positive and clockwise negative. So M1 it is anti-clockwise, so positive, and M2 clockwise, so negative, minus 2. So answer is minus 2 Newton meter. Now either you can write minus 2 Newton meter or you can write 2 Newton meter and in bracket you can write clockwise. Because this minus is indicating the direction, so instead of writing minus you can also indicate the direction in bracket. Okay, so this was question number 4. We move to 5th question. Two forces, each of magnitude 10 Newton. So there is a figure given. Each of magnitude 10 Newton act vertically upwards and downwards, respectively at end A and at B, of a uniform rod of length 4 meter. So total length is 4 meter. Okay, read the question and keep drawing your figure. In physics, figures are very important. Which is pivoted at its midpoint. So O is midpoint. So this is 2 meter and this is 2 meter. Total is 4. This is midpoint, 2 meters. Determine the magnitude of resultant moment of forces upon the pivot O. In short, they are asking what will be the total moment due to forces at A and B if your pivot point is O. So total moment will be addition of two moments M1 and M2 due to this force and due to this force. Because whenever they are asking total resultant means add moment due to all the forces. M1 is, so we will separately calculate them. Your M1 is force 1, let this be force 1 and this be force 2. F1 into distance. What is your force 1? 10. What is distance between your pivot point and F1? 2 meter. So this is 20 Newton meter. Now direction, don't forget the direction. So it is upwards and pivot point is at O. It will try to create a clockwise moment. So this is clockwise. And for M2, force into distance, again your force is 10 and distance between B and O is 2. The point where force is applied and the pivot point, that is your distance. Again 20 Newton meter. What type of rotation it will apply? Pivot point it is here and force is applied downwards. It is trying to create a clockwise rotation. So again clockwise. So here I will be writing 20 clockwise plus 20 clockwise. So total answer is 40 Newton meter in clockwise direction. This is question number 5. If both of them are in similar direction, they will add up. If they are in, if one is clockwise, one is anti-clockwise, then subtraction. We will move to question number 6. So question number 6. So there's a figure provided. At A, there is a force in upward direction of 10 Newton, and at B, there is a downward force of 10 Newton. There is a center point O. Distance between the A and B is 50 centimeter. The figure shows two forces each of magnitude 10 Newton acting parallelly in opposite directions. Calculate the resultant moment of force at point A, B and O. Okay, so they have informed at A. So first you need to consider your pivot point is A, then you need to consider its B, then you need to consider its C, and your O, sorry not C, O, and O is the midpoint. So this total is 50 centimeter, O is midpoint, this will be 25 centimeter and this is again 25 centimeter. So this was clear, this is midpoint. Okay, easy. First question, at A. So at A, the force, the moment due to this 10 Newton will be 0 because distance between A and A. Why? Because even your pivot point is A and force is also applied at A. So at A, moment due to this force is 0. Only this particular force will be applying some moment. So your moment will be F into D. What is your force? This force is 10 Newton and distance between this line and A, 50 centimeter. So 50 centimeter, first it will be written in meters, 0.5. So this will become 10 into 0.5, 5 Newton meter. Case 2, at B. Now what will happen at B? At B, this particular force will not apply any moment. Okay, it's like if I'm having this pen, I'm pivoting at it here, this point here. Okay, I apply force on this end, the pen will not rotate. But if I apply force at any other point, pen will rotate. But at the pivot point, however force I apply, it won't rotate. At B, again M is equals to F into D. Here force at A is 10 Newton and distance between them is 50 centimeter, 0.5 meter. So again 5 Newton meter. And third case, at O. Now at O, both the forces are having different line of action. So both of them will apply moment of force. So I will be writing MA plus MB. What is your MA? Force at A into distance plus what is MB? Force at B into distance. What is force at A? 10 Newton. And distance between O and A, 25 centimeter. 25 centimeter will be written as 0.25 meter. So into 0.25. Plus FB is also 10 Newton and distance between O and B is also 25 centimeter, 0.25 Newton meter. 10 into 0.25 will be 2.5. Okay, now direction is important. While adding, don't forget your directions because if your directions are opposite, it may cancel out. So at A, I have not done in the first section also. For A, when your pivot point was this, B was applying force. Okay, the A was not doing any, not providing any movement. Only B was providing a movement and downwards in this direction. It is creating a clockwise movement. While we were solving at B, if B was pivot point and this force A was applying force in this direction because pivot point is here, it is applying force in this direction. Again, clockwise. Okay, and here. Your moment at A. If O is your pivot point and A is the force applied, it will create a clockwise movement. It is very simple, I have already mentioned. Okay, if it is left hand side and upwards, clockwise, right hand side downwards, clockwise, left hand side downwards, anti-clockwise, right hand side upwards, anti-clockwise. This is clockwise and FB into D. FB, right side and downwards, again clockwise. So we can directly add them. 5 Newton meter clockwise. So all the three are 5 Newton meter and clockwise. In this particular sum your answers are same, but don't assume in all the sums the particular, if you change the pivot point, it won't change. If you change the pivot point, your total moment may change. In this case, in this question, it was not changing. Now I'll move to question number 7. A steering wheel, there is a steering wheel of 0.5 meter diameter. So the diameter is 0.5 meter. Is rotated anti-clockwise by applying two forces each of magnitude 5 Newton. You need to apply two forces and it becomes anti-clockwise. Suppose if I am applying a force on right hand side and upwards and left hand side downwards. Both of them will create an anti-clockwise rotation. And each force is of 5 Newton. Draw a diagram. So this diagram is there to show the application of forces and calculate the moment. So now we need to calculate the moment. The total distance, let this point be A and B, and this is O. Total diameter is 0.5. So this distance will be 0.25 meter and this will be 0.25 meter. They are not mentioned, but you have to understand for a steering wheel, O will be the midpoint. Now what will be your moment due to A, MA, force into distance, force is 5 Newton, distance between OA is 0.25. So this will be coming out as 5 into 0.25 will be 1.25 Newton and it will be anti-clockwise. That was already mentioned in the question. And what will be your MB? Force at B into distance. Force at B is again 5 Newton and distance between B and O is 0.25. So again 1.25 Newton. This is also anti-clockwise. Total movement will be MA plus MB. 1.25 plus 1.25. If they are same type, then add. So this will become 2.5 Newton meter and direction will be anti-clockwise. Okay, I hope this question was clear. This was question number 7. Now I will move to question number 8. Question number 8, uniform meter rule. I have already discussed what do you mean by uniform meter rule. There is a ruler of length 100 centimeter or 1 meter. So from 0 centimeter till 100 centimeter. This is a uniform meter rule. Its weight is uniformly distributed. Okay. A weight of 50 GF is suspended at one end of it. Let 50 GF be at this end. 50 GF mass suspended means it is applied at this point. Okay, it is attached. Is suspended at one end. Where should a weight of 100 GF be suspended? And very important point, it is pivoted. Your scale, your ruler is pivoted at center at 50 centimeter. Okay. Now you need to apply 100 GF. You need to find where should we apply 100 GF so this becomes balanced. Right now you can understand if you apply any weight on any one side, 50 GF you are applying on at this particular end. So the scale will try to move in this direction, anti-clockwise direction. So obviously you need to apply 100 GF on the right hand side of your pivot point. If you apply weight on that side, then only it will get balanced. Okay, but your weight is not 50, it is 100. So if you apply 100 here, and 50 is at here, 100 is on this side and 50 is on this side. Again it will not be balanced, but we need to apply 100 GF at such a point that it becomes balanced. So now we'll solve this sum. Let suppose your weight of 100 GF is applied somewhere here and distance between your 50 centimeter and this weight is X. They are assuming it to be X. Now that X can be anything. Okay, even if your X becomes negative, that means your weight should be in this way. If it is 50, so from 50 again 50, that means it will be at 100. So we are just assuming the distance to be X. Once you have value for X, then we will decide where it is to be placed. Okay, so two forces are applied here. This will create, because it is balanced, so we need to apply as per principle of moments. So in all the sums where in question they have mentioned that the ruler or the object is balanced, it is in equilibrium, it is not moving, that means it is balanced. So your all the clockwise movements and all the anti-clockwise movements are equal. As per principle of moments, sum of clockwise movements is equals to sum of anti-clockwise movements. Here this 50 GF left hand side and downwards will create an anti-clockwise movement. So it is 50 GF and distance from pivot point is 0 and 50. 50 centimeter. Distance between 50 and 0 is 50. And sum of clockwise movement, this 100 GF which is applied at this side, it is on right hand side and downwards. This will create a clockwise movement. O is pivot point, right hand side of pivot and downwards will create a clockwise movement. Weight is 100, so force is 100 and distance between pivot point and this. So it will be 50 and this is x. Let this point be x. Okay. So we are considering this distance, total distance to be x. The total distance I am considering is x from 50. So let this be x. Please understand, I have not taken this point to be x. I have taken this distance to be x. So here I write force into distance. Moment is force into distance. Force is 100 because your weight is your force and x is your distance. Now 100x and 50 into 50. Now understand, again I am not converting centimeter into meter because on left hand side also I am taking centimeter and right hand side also I am taking centimeter. In such case, even if you don't convert, it's okay. So 50 into 50 is 25. 100. This 100 will go in division and x will be 2500 upon 100. So 25 centimeter. So what is your distance of x? 25 centimeter. So distance between this point and this point is 25 centimeter. This is already 50 centimeter. Now more 25 centimeter. So this will be 75 centimeter. So your answer will be the mass or the weight 100 GF must be applied at 75 centimeter point mark. Or you can also write it must be applied. You can also write the statement as at must be applied at 25 centimeter from the other end. So either you can say 75 from this end or 25 centimeter from other end. Okay, both of them will mean the same thing. Either write this box or write this box. So this is how you solve movement principle of moment sum. This was question number 8. Now we move to 9th question. Question number 9. A uniform meter rule balances horizontally on a knife. So again, uniform meter rule, 100 centimeter is total length, is resting on a knife edge placed at 58 centimeter mark. So you are balancing it at 58 centimeter. Using a knife, it is balanced at 58 centimeter. And when a weight of 20 GF is suspended from one end, so you are applying 20 GF on either this end or that end. Here you need to apply your logic. See, if this is 58 centimeter, means this length is 58 and the remaining length will be, this is total is 100, this is 58, then remaining will be only 42. Because total is 100, 58 centimeter is on one end, so another end will be only 42. 100 minus 52 is 42. Now you need to apply your logic. 58 centimeter of ruler will be obviously heavier than 42 centimeter of ruler. Okay, so this part is heavier, this is lighter. So this will try to move downwards. But they have mentioned that the scale is balanced and 20 GF is applied. So 20 GF must be applied at that end and not at 0 end. They have already mentioned it is at end, but which end they have not mentioned. That you need to apply your logic. The part which is having lesser length will be having lesser weight. So you should add load on that inside so it becomes balanced. So 20 GF is applied at 100 centimeter point. Now, so your first question. So the first was draw the diagram done, and what is the weight of the ruler? Now we need to calculate weight of the ruler. Okay. Whenever they are asking to calculate weight of the ruler, don't forget that your ruler is also having some mass, okay, which is to be considered, and that mass will also try to create a movement. It will try, because that is mass, the weight will try to pull it downwards. If you are trying to move it downwards, it will try to create a rotation. And for a uniform meter rule, you should always consider the mass at 50 centimeter mark. For 100 centimeter, the midpoint is 50 centimeter, and let the total mass of the ruler be m. Total mass, total weight of rule at center. Okay. So now we are having two forces. First is this m and another is 20 GF. But balanced, you are in balanced condition, so you will apply principle of movements. Principle of movements. So sum of anti-clockwise movement will be equal to sum of clockwise movements. Sum of anti-clockwise movement and sum of clockwise movement will be same. Anti-clockwise. Now, the load applied on left hand side of the pivot point and downwards will create anti-clockwise. You can consider this is your pivot point. If I apply force here in downward direction, it is creating anti-clockwise. And if I apply downwards here, this 20 G, then it will create a clockwise. So anti-clockwise will be mass, force is m, and distance between the mass and the pivot point, 50 and 58. 58 minus 50. And clockwise movement, your weight is 20 and distance, this is 58. Don't take 50, your pivot point must be taken. Force is applied at 100, weight is applied at 100, and pivot point is 58. So distance will be 100 minus 58. Now you can solve this. 58 minus 50 will be 8, and 100 minus 58 is 42. 20 into 42 will be 840. This 8 will go in division. 840 by 8. So your answer, if you cut it, 105. Now what will be your unit? Because we are considering the units to be same. So if this is GF, the 105 is also GF. Okay. Why they are not written in gram? Because gram is a unit of mass. Right now we are dealing with weight. Weight is a force. And I have already explained you GF, KGF, Newton, they all are unit of weight. This is force, which is also a weight. This is question number 9. Now I will move to question number 10. The diagram below. So the diagram is already part of the question. Is provided. A meter rule is provided. You can see the pivot point is at center because 10, 20, 30, 40, 50 is on left hand side and similarly 50 is on right hand side. So this is your pivot point is at center. 10, 10, 20, 30, 40, 10, 20, 30, 40. So this is your figure. Now 40 GF mass is applied at this part, this point. 40 GF weight is applied. This weight will be pulling the scale or the ruler downwards. The diagram shown shows a uniform bar supported at the middle point O. A weight of 40 GF is placed at a distance of 40 cm to the left. How can you balance the bar with a weight of 80 GF? Okay, so I have already solved this kind of question. We need, obviously this will not be in balance condition right now, only 40 GF is applied on one side. So you need to apply another load on right hand side. They have already provided 80, but we don't know the location. So let your 80 GF be at this position and distance may be x. We need to find out the distance. It's very easy. Principle of movement. So sum of anti-clockwise movements is equals to sum of clockwise movement. What will be your anti-clockwise movement? It will be due to this one. What is your weight? 40. And distance from pivot point. This is 0, this is 40. This is 0, this is 40. So total distance is 40 minus 0. And for clockwise, the weight is 80 and your distance is x. So 40 into 40. This is 80 into x. It will be 1600. This 80 will come under division. 2. Now because I am considering this 40 centimeter, not 220, so this will be also 20 centimeter. So your x is 20 centimeter, means at this point, right hand side, 20 centimeter on right hand side. So your answer is 80 GF must be applied at 20 centimeter mark on right hand side so that your ruler is balanced. Okay, so this was your question number 10 and we will move to question number 11. A figure. So they mentioned there is a figure in your question. See on the next page. There is a ruler again. There is a center pivot point. Here they mentioned this is at 50. Here this is 0, 10, 20, 30, 40, 60, 70, 80, 90 and 100. This is your ruler. Two loads are applied. First load is at 10 centimeter mark of 40 GF. And another is at 90 of 20 GF. So your question is, first question is the meter rule in equilibrium? What do you think? This is 40 GF and this is 20 GF. So how do you find if it is in equilibrium or not? Just calculate the movements. This is 40 GF and distance from center is, force is 40 and distance from center is 50 and this is 10. So difference is 50 minus 10. 40 into 40. 1600. Okay. This is clockwise, anti-clockwise. And for this one, your force is 20 and distance between this point and center point 90 and 50. So 90 minus 50. 20 into 40, 800. So both the movements are not equal, clockwise and anti-clockwise are not equal. So as per principle of movements, it is not in equilibrium. Okay. So unit if you want, this is GF centimeter. GF centimeter. So no. First answer will be no. If not, how will the rule turn? Now you need to understand in which it will turn clockwise or anti-clockwise. See, 1600 is more, 800 is there. So obviously it will move in this direction. 1600 moment was calculated due to this load. This load is on left hand side and downwards, means anti-clockwise. 800 is on right hand side and downwards, means clockwise. So total movement will be 1600 minus 800, because I have told you anti-clockwise is positive and clockwise is negative. So 800 GF centimeter in anti-clockwise direction. Why? Because your answer is positive, that means anti-clockwise direction. Now the third question. How can the second part, yes, the second part, how can the rule be brought in equilibrium by using an additional weight of 40 GF? Right now, the ruler will try to move anti-clockwise. Okay. So what you need to do, you need to provide an additional movement which is clockwise direction. This additional weight is trying to move in anti-clockwise direction. Okay, it is trying to move in anti-clockwise direction. You need to apply some load so that it is in clockwise. So this clockwise, anti-clockwise cancel out. Okay, so you need to apply a load of 40 GF. Obviously, it will be on right hand side because right hand side downwards will be clockwise. So we will apply 40 GF somewhere. We don't know the location. We'll take distance from center as x. Okay, distance as x. Now it should not apply more moment also. If this 40 GF is applying more moment, then again the ruler will not be in equilibrium. The 40 GF, the extra load you are applying, should give movement which is equal to this total movement right now. Right now it is 800 in anti-clockwise. So your this extra load should apply 800 in clockwise. It will get cancelled out. So I'll consider this is applying 40 into x will apply 800. So total movement you want is to be 0. Right now it is 800. I'll just rub this. You want in second situation, second case, total movement must be 0 or total clockwise, sum of clockwise, or as we write, sum of total anti-clockwise movement must be equal to sum of clockwise movement. This is total anti-clockwise, so 800. And now what will be clockwise? Now don't consider these two loads again. I have already calculated them and from that we have got this figure. This extra load, 40 into x, distance from pivot point is x. 800, 40 will come under division, so this is 20 centimeter. X is 20, 20 from pivot point, that is 70. So my answer is 70 centimeter. So 40 GF must be applied at 70 centimeter mark. Don't write, if your answer is 20, don't write directly 20 because this 20 is from the center, from 50. If you move 20 on right hand side from 50, it will be 70. So your answer is 70 centimeter mark, so that your ruler becomes in equilibrium situation. This was question number 11. We'll move to 12th question. When a boy weighing 20 kgf sits at one end of a 4 meter long seesaw, so there is a seesaw, total length is 4 meter, and a boy of 20 kgf is sitting on one end, is applying 20 kgf. He is on one of the ends. It gets depressed at this end. How can it be brought to the horizontal position by a man weighing 40 kgf? Now they have not mentioned that this seesaw is balanced, where it is balanced. So we will consider at the center point. If they have not mentioned, consider that it is pivoted at center. So total is 4 meter, this will be 2 meter distance. There is another person of weight 40 kgf. He should sit on the other end such that the seesaw is balanced. Okay. So let us consider that person is sitting somewhere here at a distance of x from center and he is of 40 kgf. Again balance, principle of moments. Sum of anti-clockwise moment is equals to clockwise moments. Anti-clockwise will be created by this. So 20 kgf into 2 meter, and this one is 40 kgf into x meters. This is 2 into 20, 40. This is 40 into x. 40 will come under division. 40 upon 40 is 1 meter. So here x is 1 meter. That means the distance is 1 meter. This was your center point. So this was center point. So 1 meter on the other hand. Check your answer. So this 40 kgf person, a person having weight of 40 kgf should sit at a distance of 1 meter on the other hand. Okay. So this is question number 12. I will move to 13th question. A physical balance has its arms. What do you mean by physical balance? The tarazu. Okay. Physical balance is having, so it will be having two arms like this. This is a rough diagram. This is the physical balance I am having. Okay. Has its arm length 60 centimeter and 40 centimeter. So this is 60 centimeter. One arm is of 60 centimeter and another is of 40 centimeter. What weight kept on pan of longer arm? This is longer arm. What weight should be kept so that it balances out? If the weight on other end is 40 gf, 100 gf. Again same thing, let here the weight be x. So moment due to x into 60 will be equal to 40 into 100. Because it is in balance situation. So this distance into force and this distance into force will be equal. This is 4000. So x will be 4000 upon 60. And your unit must be same as this weight. Gf, so this will be also x. 400 upon 6 or 200 upon 3. If you cut it, it will be 200 upon 3. Or if you just convert into decimals, it will be 66.67 gf. This was question number 13. We'll move to 14th question. Question number 14. 14th, there is a diagram provided, a ruler, okay, and it is pivoted at a point O. There are two other points A and B. A is at a distance of 40 centimeter and B is at a distance of 20 centimeter. Weight at A is 150 gf and weight at B is 250 gf. Okay, so there are two weights, 150 gf and 250 gf. One is at A and one is at B. The question is the total anti-clockwise movement. First part, second is total clockwise movement, third is the difference, and fourth is a different question. So we'll solve first part, second part, third part, very easy. The first part, the total anti-clockwise. This will be creating a clockwise movement and this will create an anti-clockwise movement. So total force is 150 and distance is 40 centimeter. So it will be 6000 gf centimeter. Second part, clockwise. So your weight is 250 gf and distance is 20 centimeter. So it will be 5000 gf centimeter. And what's your difference? So always bigger minus smaller. 6000 minus 5000. So it is 1000 gf centimeter. And this is anti-clockwise, this is clockwise. So anti-clockwise was positive, clockwise is negative. The answer is positive, that means this is also anti-clockwise. If your answer is positive, anti-clockwise. If your answer is negative, clockwise. Now the fourth part of this question they have told is, if at the distance from O, 100 gf should be placed so that it becomes in balance situation. 100 gf additional, so we have already done this kind of stuff. The total movement right now, the resultant movement, both of them are applying some movement, so there will be a resultant movement applied. Okay, here it was trying to pull it with 6000, here it was trying to pull with 1000. So eventually the resultant is here additional 1000 gf was applied, 1000 gf centimeter was applied. So we'll apply 100 gram on that hand side. What we need to do, we need to balance This is anti-clockwise. You should apply 100 GF such that it creates clockwise. Clockwise, anti-clockwise will cancel out each other. Apply 100 GF on right hand side and let the distance be x. Okay. Now this 100 into x, 100 into x will apply some moment. That moment must be equal to this one, so that it becomes balanced. So 1000 is equals to 100 into x. 100 will come on this end. Your x is 10 centimeter. Okay, so from O you should apply 100 GF at 10 centimeter. You can see, if you applied this at 10 centimeter on the right hand side of O, your ruler will be balanced. Please understand what I have done is, there was anti-clockwise movement, there was clockwise movement. Okay, first I added them. But while adding, please pay attention, clockwise will always be negative. Whatever answer is there, that is remaining. Suppose you are earning 100 rupees, you are spending 60 rupees. You are earning 100, spending 60. What is your remainder? 40. So that 40 is your remainder. Similarly, 1000 is remainder. In question they are asking how you should spend this 40 so that your total amount with you is 0. Okay. For that, this 100 GF and x is provided. 100 into GF, 100 into x must be equal to the remaining part. So it will be answering. This was question number 14. I'll move to 15th question. A uniform meter rule of weight 10 GF is pivoted at 0 mark. So this is a uniform meter rule, 0 centimeter, 100 centimeter. Now it is pivoted here itself. Okay. And the weight of ruler is 10 GF. The weight of your ruler is 10 GF. And it will always be at center at 50 centimeter. 10 GF. Weight of the ruler, there is no other weight. Weight of the ruler itself is applied at the center. What moments of force depresses the ruler? So what will be the moment? Moment will be the force or the weight and the distance. Though it is pivoted at 0, this is 50. 50 minus 0. So 10 into 50. 500 GF centimeter. And what will be the direction? Right hand side of the pivot and downwards. So clockwise. Right side of the pivot and downward is clockwise. Now, how can it be made horizontal? By applying the least force. So you want to apply least force and make it balanced. Now understand. The least force means go as far as possible from your pivot point. This is your pivot, you can go till this point. And the force must be upwards because this is downwards, it is creating clockwise. If you apply upwards, it will create anti-clockwise and this will balance out. Okay? There is some force applied, but we don't know how much force must be applied. Principle of moments. Whenever it is about balancing, then it will be principle of moments. Sum of anti-clockwise movement is equals to sum of clockwise movement. This is creating anti-clockwise. So the weight, let the force be F, and distance between 0 and 100 is pivot point and point of application. Pivot point and point of application is 100. And for clockwise, this particular scenario. So 10 is your weight and distance between them is. This is centimeter, this is centimeter. They will cancel out. This is GF, so your answer will also be GF. 100 will go in division. So 5 GF, force of 5 GF must be applied at 100 centimeter mark. Why 100 centimeter? Because they have asked us to calculate the least force required. Force is least, distance must be maximum. So we are going as far as possible. This was question number 15. Now I will move to question number 16. Also don't forget to mention this upward direction. Very important. Question number 16. A uniform half meter rule. Half meter is only 50 centimeter. So this is 0, this is 50 centimeter. Half meter is only 50 centimeter ruler. Can be balanced at 29 centimeter mark. it is balanced at 29 centimeter. When the mass of 20 gram is hung from its one end. So if this is 29, this is 29 centimeter, and the remaining part will be only 21 centimeter. Because total is 50, this is 29, this will be 21. 20 GF is suspended from one of the ends, but you don't know which end. I have already told you the shorter part will be having the mass, so that it is becoming balanced. So 20 GF is applied here. And this particular ruler will also have some mass. It will be at center. Let that mass be M. And the center point is 25 centimeter. Total is 50 centimeter, so your center will be 25 centimeter. Okay, so the question is a uniform. Okay, draw a diagram of the arrangement. So diagram is drawn. Find the mass of the half meter. We need to calculate this M. Principle of movement. Whenever it's about balancing, principle of movement, it is in balanced situation. So sum of anti-clockwise movements is equal to sum of clockwise movement. Now left side downwards will create anti-clockwise. So 20, the mass is M, and distance, this is 29 and this is 25. So 29 minus 25. And for clockwise, the weight is 20 and distance is 50 and pivot point 29. 50 minus 29. 29 minus 25, 4. 50 minus 29 will be 21. 20 into 21 will be 420. This 4 will go under division. So this will be 105 GF. That means weight of your uniform half meter rule is 105 GF. This was question number 16. Now I will move to 17th question. A uniform meter rule of mass 100 gram is a uniform meter rule 0 centimeter till 100 centimeter. It is having some mass. It is having some mass of 100 gram. Mass of the ruler will always be at 50 centimeter until unless they have mentioned something else. You need to consider the entire mass will be at center, which is 100 grams. This balance on a fulcrum, nothing but there is a support. Sorry. This fulcrum is at 40 centimeter mark. So that fulcrum is at 40 centimeter. Be suspended by unknown mass M at mark 20 centimeter. So at 20 centimeter there is some mass M. And this is in balance situation. Okay, they have already told this is balance. Calculate the value of M. Again, principle of moment, this weight M into distance 40 minus 20. This is anti-clockwise will be equal to clockwise 100 into 50 minus 40. Distance between point of application and pivot. This is 20 and 50 minus 40 will be 10. This 20 will go in division. So this is 50 grams. Why I am taking G gram? Because here this is gram, so your answer will also be in gram. So M is 50 gram. This was your first part. Now in second part, they are asking you what will happen if you shift the mass to 10 centimeter. Which side the ruler will bend? Now if you shift this load from 20 centimeter to 10 centimeter, we are shifting this load from 20 to 10. So now understand, your movement is always force into distance. Now the distance has increased, D has increased. Because D has increased, movement will increase. What kind of movement is this applying? Anti-clockwise. Downwards, left side, anti-clockwise. So a ruler will tilt in anti-clockwise direction. Okay, so this will try to move in anti-clockwise direction. this side. So second answer must be on side of M. The ruler will go down or anti-clockwise. Third part. What is the resultant movement now? What is the total movement or resultant movement right now? So again what we can do is, here they have not mentioned that it is balanced. Obviously it is not balanced. Calculate the total movement. So moment due to this force, let be M1. Force is, your M was 50 gram. I have already calculated M to be 50 gram in your first part. 50 into distance. What is distance between pivot and this? 40 minus 10. And M2 will be due to this one. 100 into distance is 50 minus 40. Resultant means calculate all the movements and then add or subtract. M1 is 50 into 30. 1500 gram centimeter. 1500 gram centimeter. And M2, this will be 100 into 10. 1000 into gram. Now gram is not allowed because gram is just a mass. So for in case of weight, when you need to consider this gram as weight, just write GF and not G. This will also be GF. M1 is 1500 and M2 is 1000. Okay. Now what will be your resultant? M1 is in anti-clockwise direction and M2 is in clockwise direction. So total resultant movement will be M1 minus M2. Why? Because this is clockwise. Clockwise is always negative. So 500 is your answer. Positive answer means the movement is anti-clockwise. This is resultant movement. 500 GF centimeter in anti-clockwise direction. Fourth part, how it can be balanced by another mass of 50 gram. So you are applying another mass of 50 gram to balance this ruler. Right now it is anti-clockwise. So we will apply 50 GF on that side. So it becomes balanced. Right? The weight is, the weight they have mentioned is 50 GF. You need to find the location, 50 gram. So let your 50 gram be somewhere here. How to find the side, right side or left side? This is anti-clockwise, you need to create clockwise. So you need to select right side. If you need to create anti-clockwise left side, you need to create clockwise right side. We have also solved this kind of sum. Now this resultant will be equal to the moment created due to this new mass, 50 into x. The resultant, we have already done such sum, the resultant will be equal to the new one because we want to balance it. 50 into x. 500 upon 50 is your x. This will be 10 centimeter. X is 10 centimeter from the 40 centimeter mark. So it is 50 centimeter mark. So at 50 centimeter, 50 gram must be placed. Go through each part slowly, understand, write, and if you don't understand, do contact me. This is a new concept, but the sums are almost today, all the sums were of principle of movement. This is question number 17. So your answer is 10 centimeter. Don't write your final answer is not 10 centimeter. 10 centimeter from pivot point on right side. So it will be 50 centimeter mark. So at the middle point here, you should apply 50 gram. Okay. This was 17th question. We'll move to 18th question now. Last question of the exercise. So in 18th question, there is a figure, there is a ruler, a uniform bar of length L meter, total is L meter, is supported at its end. There are two supports by a weight W and there is a load W at its middle. Find the reaction R1 and R2. Now understand reaction whenever there is a ruler. If this is a ruler, okay. If I am applying load at center, these two ends will try to create a force such that the bending happens. Okay, The load will apply at center and this too will apply a reaction force in upward direction. Weight is in downward direction. You are attaching this. If I am applying some load here, these two ends will try to pull it upwards. That upward force is reaction force. You might have seen you have a ruler. Try to bend it from center. Both the ends will come up. Why they are coming up? Because a resultant force is applied on them. Okay, reaction force. A reaction force will be applied on both the ends. Okay. How can we calculate this? It's very simple. The total load is W, which is applied at center. If you are applying the total load at center, which is W, then resultant R1 and R2 will be half of it. Whatever force you apply at center, it will get distributed to both of them equally. So your R1 is equals to R2 and both of them will be W by 2. This reaction force will be W by 2. And you need to calculate reactions R1 and R2. So this will be W by 2 and W by 2. Okay, I hope this is clear. The weight which is applied at center, because it is at center, then it will be getting divided equally with R1 and R2 and both of them will be half of the total weight, W by 2, W by 2. So this was your end of part A, chapter 1. Now in next video we will be starting chapter 2. Please solve all the sums carefully. This is a new topic. You need to do it